All right, let's get started right away. Answers for the review sheet are up there on the cart. If you need those. What number do we want to start with? 5.
Yes. I overthought this one. Okay, guys, leave me alone. Megan, I overthought it. Leave me alone.
Bro, what? This is like what? This is
It takes 5 seconds. You'll be fine.
I had one letter for the answer. Why do you
Everyone should have.
We all need to respect each other's opinions.
Tell us where you please.
What did you say, Megan?
It's nothing, right? E,
I don't
nothing.
know. I don't think it's right.
E. E. E.
So the dots represent air,
Yup.
right?
Yup.
So what's going to be between the dots?
Nothing.
What I don't know what else would be in between them. It's just air, right? Empty space. Yeah.
That's what I had. I told you I overthought it.
Yeah. Don't overthink it. Okay.
Okay.
Okay. We'll draw number 6. So here's number 6. Here's my water, right? It's gonna be a very good drawing. Here's my straw, right? Here's my straw. Here's my hand. Oh. Oh boy. Wow.
Wow.
Oh.
Let's try to draw better fingers. Okay, there's my hand. So then I take the straw out of the cup, right?
Okay.
And then there's some water here, right? Yes?
Oh, I was looking at.
What type of pressure do I have in this part where there's no water?
Low.
Low pressure. What is the atmosphere doing? Blowing this water up the straw. Because there's lower pressure in this small open space than the atmosphere. So it's blowing the water up the straw. So that was that one. Next question.
34.
34.
Pardon
Okay.
the interruption, but at this time, after attendance has been taken, if any 10th graders need picture retakes, please see your way to the packed lobby after attendance.
Okay, so on 34, we're looking at something different for each one of these scenarios, right? So for 34A, we are looking at pressure. Agreed?
Yeah.
And how do we define pressure? It's force, right? Also known as collisions, right? Over area. Yes?
Yeah.
So higher pressure is going to be what? More particles, right? Or a smaller box. Yes?
So like 3 and 7.
So what's going to be the least pressure?
Oh.
It's going to be the least pressure.
2.
2, right? Why not 4?
Because
Where's more molecules?
no, they're equal.
2 is equal to 4.
Yeah.
Same amount of particles. It also says at the same what? It doesn't say we're changing the temperature, right? At the same temperature. Yes? 2 is equal to 4, right? No, it doesn't. I'm sorry, 2 is equal to 6. 2 is equal to 6. That should make more sense. Roman numerals are hard. Okay? 2 is equal to 6, which is going to be less than what?
Probably like 1 and
1, which is going to be equal to 5, which is also going to be equal to what?
maybe 8.
Which is also going to be equal to 8. Why did I put less than? Which is also equal to which other one? 4. Those are all equal. Right? Which is less than I 3, which is equal to 7. You got it. So that's A. What about B? The average kinetic energy.
They all the same.
Same.
No, it's the, what's the other one that I confused?
They're all the same.
Yeah, but, well, yeah.
D, root mean square velocity. Well, C is just density, right? So C is going to be the mass of the particle divided by the volume of the box. So that's not that hard to figure out for C. But C, do you want me to write the answers here really quick just to make sure you got it? So the lowest density is what? Lowest mass over the largest volume is going to be 2, right? So 2 is going to be less than what? 1, which is going to be equal to 4, which is going to be equal to 6, which is going to be less than 3, which is going to be equal to 5, which is going to be equal to also 8, which is going to be less than 7. Going to be less than 7. So that's your density one. Now, root mean square velocity. You need to kind of look up what that means. Root mean square velocity depends on temperature and the molar mass. So now you have to account for temperature and the molar mass. Well, is the temperature changing in any of these? No. Is the molar mass changing between 1 and 4? Yes. No. 1 and 4 are all the same molar mass. Is the temperature changing between 5 and 8? No. Which one is lighter? Which one is heavier? Argon is heavier. So, lowest to highest, root mean square velocity, right? The heavier ones are going to move how? Slower. So this is going to be V is equal to 6 is equal to 7 is equal to 8, which is going to be less than, right? 1, which is equal to 2, which is equal to 3, which is equal to 4. So that was it on that one.
I won't be on the test, right?
I could see something like that being a multiple choice question.
Can we do 7? Or
7?
75.
Is that the next one?
No, 58.
Dog.
Anything before 58? Anything before 58? Anything before 58? Okay. 58. On 58, person accidentally swallows, I don't know how this happens, a drop of liquid oxygen. That's unfortunate.
Like just straight liquid.
Yeah. Which has a density of I doubt it, all right, which has a density of 1.149 grams per milliliter. Assuming the drop has a volume, 0.050 milliliters, what volume of gas will be produced in the person's stomach? At body temperature, 37 degrees Celsius, and a pressure of 1 atm. On 58, we know we're going to have to get it to what eventually? What am I going to have to eventually do to this? Pivnert.
Yeah.
So on 58, the first thing to do is figure out moles.
Oh, okay. It's not a question.
Okay. So
we could work it out.
are we good on 58 or no? Should we move to something else?
45.8 or 0.0458 liters.
You add 46 milliliters.
Okay, yeah.
So that's fine.
Okay. It's probably
What? Are we good with that or no?
We're good, yeah.
Do you want me to throw my answer up really quick, just so you can see it? So what I did on 58
Yeah.
is I worked milliliters, used the density, grams to moles, and then I Pivnerted it.
Yep.
So here was your rate you had to save.
62, I have like a minor question about.
Okay, 62.
So, combined gas law. You said you could leave the temperature in Celsius, right? Because as long as they're not negative.
Why are you using the combined gas law on 62?
Because you have P1.
That was the one that I had a question for you about, where it's like the volume increased by 4%.
Yeah, so I just made V2 1.04.
Yeah.
What did you get for 62?
I got 220.14 PSI.
We got 5.6 atmospheres. So probably something.
62?
Yeah.
So,
So I have an ideal gas with 500 milliliters, right?
so a bike is filled with air pressure 75 PSI. So that's
Yes.
P1.
Yes.
P1 is 19 degrees Celsius. Riding the bike on asphalt on a hot day increased the temperature to 58, so T2 is 58. The volume of the tire increased by 4%, so that means V2 is 2.04.
2.04?
1.04.
Mm-hmm. So you assume that V1 was 1 liter?
1 liter.
Okay.
And then I solved for P2. But my question was, I used Celsius because they're not negative temperatures.
And what did you get?
I got 220.14.
And I got 82 PSI because I did mine in Kelvin.
Okay, but can it be done in Celsius and still have it? Is that still the right
I
answer?
did Kelvin and Atlas.
I did Kelvin, what'd you get?
I got like.
Well, the question asks, it says, what is the new pressure? So it doesn't really specify what your pressure needs to be in.
So you had what was your answer?
So I had 220.14
220.14 what?
PSI. But
PSI.
I used Celsius. I used Celsius.
All right, so what was your Celsius? I want to work this out.
70 degrees and 58.
So
75 times 1.0.
75 times 1.
1.0 over 19 degrees Celsius.
I'm going to do it times, what was the other temperature?
58 degrees Celsius.
Times 58 equals, divided by,
19.76 P2.
divided by,
Because I cross product.
I'm solving for P2,
Yeah.
right? So divided by,
19.
what was your second volume?
1.04.
1.04, divided by, what was your T1?
19.
19. 220.
Yeah. So
Let's just do Kelvin no matter what. All right? Let's do Kelvin because Kelvin is based on absolute zero.
okay.
So let's just stay Kelvin. All right? Whenever you see a gas law problem, let's work it into Kelvin no matter what. Because all of these, I guess all of these laws were based off of like ideal gases. And ideal gases are based on STP.
Now, what's the conversion from PSI to ATM? Because I don't know that one.
I gave it to you in the notes.
PSI?
Yeah, it was.
I did.
Oh.
It's 1 atmosphere is 14.7 pounds
Oh,
per
okay.
inch squared.
Yes, I gave that to you. So let's make our attempts Kelvin always from this point forward. That way we are all the same.
Otherwise, it will crash around you.
Okay.
Yes. Or Mr. Knight will shoot a bottle into my face.
Yeah.
My gosh. 75?
Okay, what'd you get
Is
for
that the one
75?
that's like?
This one with the balloons.
I got 2.6 times 10 to the 7th grams.
What's so fair, guys?
Bed.
I got
So you're close.
8.4 something.
All right, we should probably do it.
No, I got 2.7 times 10 to the 7.
That's fine.
Okay, let's see if I can follow my work.
Let's do 75.
I got,
Let's do 75. 75, I am given volume of a balloon. Hydrogen gas was estimated at 20%. What mass of iron splints and 98% by mass H2SO4 are needed to complete the filling of the balloon? Who was off by like two numbers? Was that you, Jack?
Yeah, I just had I had 10 to the fifth. I had 2.6 times 10 to the fifth.
Okay.
So it's
I have a
probably something-
feeling I know what you did. All right, first thing I would do is I'd figure out my number of moles of H2.
Yeah.
So my NH2 is going to equal PV over RT. So I'm going to take 1.0 atmospheres times, I need this to be volume in what? Liters. We know that if there's 4,800 meters cubed, yes?
Wait, but it's only 80%
Hold on.
Oh,
of. Okay, sorry.
Hold on.
Sorry.
On 75, I have 4,800 meters cubed, and I know that 1 meter cubed is how many centimeters cubed?
107 meters cubed.
100 centimeters cubed. This is all in parentheses. And I know that there is 1,000 centimeters cubed in 1 liter.
This is absolutely disgusting.
So there's a little conversion you have to do there
Okay.
to get it to liters. You can do that before, after, within it. Over 0.08206 liters times atmospheres over moles times Kelvin times 273 Kelvin. Because this is at what? Oh, it told me temperature of 0, pressure of 1. So my number of moles of H2, I ended up getting 2.1 times 10 to the 5th moles of H2. But that is only 80%. So I have to take this number times what?
0.2. Or no.
Times 0.8, right? Times 0.8. So my total H2 is 2.6 times 10 to the 5th, right?
Okay, I got that.
Oh, that's because it's 80%.
Moles of H2, because it's only
basically,
80%.
Is it like
I'm not done yet, though.
wrong? I did like 80% of like 4,800.
I did that too. And then I got 6,000 meters cubed.
I got
too,
it.
And then I did the conversion. But it's the same thing.
It should be the same thing.
It's literally the same.
Should be the same thing. All right?
Okay.
You have to multiply by 0.8 at some point. Let's see what happens when we finish it.
And it's 80%. That is because we lost 20% of the hydrogen gas we'll fill.
We
Correct?
should have worded that differently.
Yes. So now I need to get my moles of H2 to what?
Moles of the other two.
Fe and H2SO4.
Yeah.
Right. So I'm going to take this on 75. I'm going to stoich this, right? So I have to take my 2.6 times 10 to the 5th moles of H2. I need to get that to what? Grams of Fe, right? So I'm going to say for every 1 mole of H2, wait,
Multiplying by 0.8 or you dividing by 0.8?
I multiplied.
Shouldn't that make it smaller?
Oh. Oh yeah, why did it make it bigger? Can I come in 6th period, please?
Come in 6th period, please. Yeah, you're right. That number is bigger.
That is bigger. That's way bigger.
Oh,
Go by 0.2.
I made it at 20%.
Yeah, because if you multiply by 0.2 of that,
I'm on.
I do the ratio thing.
It says
I
we
just write
assume
it.
100%. Oh wait, no, is that for the reaction?
Yes,
or is that
the
for
reaction.
If you
hydrogen?
just do
no, I did the right thing here.
4,800 over 80 equals n over 100, that makes the most sense in my brain.
Either way, it's fine. Either way, it's fine.
How do we do it?
What? Oh wait, no, because the sig digs is only 2 and it's such a big number, I don't think it even
I
matters.
swear to God, Jack.
All right. 1 mole of H. Let me finish this out. 1 mole of H2 is to 1 mole of Fe, and 1 mole of Fe is 55.85 grams of Fe. Let me put this in my calculator. So I have 2.1 let me put this. 2.1 E5 times 0.8.
Or yeah, I just went straight to moles.
Yeah, I think there's a mistake here.
Pardon the interruption.
This total H2,
If there are any 11th graders.
this should be smaller, right?
Yeah.
Please make your way to the PAC lobby.
80% of something should be less.
Yes, it should be smaller.
Wait, so are we adding or subtracting? Because the problem doesn't make it clear if we are subtracting from the 48 or we're adding to the 48.
So on
What the volume of the balloon?
Oh,
the volume of the balloon was 4,800 meters cubed. The loss of hydrogen gas was estimated at 20%. So we only got 80% that was put in.
So the start there should have been like more. There should be
So either you
more-
can subtract 20% or multiply it by 0.8.
Yeah.
So we lost.
How did we get a bigger number?
No, I think there's a mistake here in my math.
Oh.
All right. So if I multiply that by 0.8, this is actually 1.6. It's actually 1.68 times 10 to the 1, 2, 3, 4, 5th
Okay, that's closer to what I got.
moles of H2. So this should be 1.6, essentially. Really 1.7.
Okay.
That should be 1.7 times 10 to the 5th moles of H2. That makes more sense. Because it should be smaller, right?
Yeah.
Multiply this through. So 1.7 E5 times 55.85. So this gives me 9.5 times 10 to the 1, 2, 3, 4, 5, 6 grams of Fe.
What I don't understand is, I'm sorry, I'm still bringing this up. I don't understand why it's getting smaller because it said when it's completely filled up.
80% of Jack.
Because when it's filled up,
100%.
But.
so when it's filled up, this is the total volume, right? Yes?
Yeah, that's after loss though.
No, it's not.
No, that's how much the balloon holds.
Are we sure about that?
Yes, the volume of the balloon was 4,800 meters cubed, and the loss of hydrogen gas during filling was 20%. They still filled the balloon, right? So that's still how full the balloon
So
was.
that's the start, and then we haven't taken the 20% off.
Correct. Yes.
So weirdly, okay.
It's a poorly worded question.
This problem.
So this is my grams of Fe. That's part 1, right? Yes? Part 2, I know, this is different. I think the book has made a mistake.
That's pretty.
All right?
Or
Yes.
we interpret it differently.
Ready?
Isn't there more than 100 centimeters cubed in 1 meter cubed?
There's hundreds. No. 1 meter is 100 centimeters,
Because the cube is cubing the.
right?
Yeah, shouldn't
How many centimeters are in a meter?
100?
So how many centimeters cubed are there in a meter cubed?
Shouldn't there be like a million?
Well, yeah, you're gonna to cube this number. It's gonna be 100 cubed. You still have to cube that.
Yeah.
Yeah, so I'm gonna cube that 100. Huh?
You wrote 100.
Yeah, I'm gonna cube that 100 in the math. So that is 100 cubed.
Does that mean that there's a...
So it is like a million.
Yeah.
Yeah.
He just wrote it.
I just didn't write it out.
You don't cube the 1,000 centimeters in milliliter though.
Here?
Yeah. You don't cube that, right? You don't.
No, because that's the same as 1,000 milliliters.
Okay.
Are we ready to finish this thing?
Yes,
Yeah.
please.
Okay.
This problem killed my family.
So now I'm going to take this same number, my 1.7 times 10 to the 5th moles of H2, and then 1 mole of H2 is 1 mole of H2SO4, right? Because you would agree that there's 1 mole of H2 and 1 mole of H2SO4, yes? And then 1 mole of H2SO4 is 98.09 grams of H2SO4. And you guys know I'd never give you a problem like this on the test. But I know that I'm only getting 98 grams of H2SO4 for every how many? 100. So there is my 98%. So there's my 98%.
Didn't do the second part, but okay.
So 1.7 E5 times 98.09 times 100 equals, divided by 98, final answer equals 1.7 times 10 to the 7th grams of 98% H2SO4. I believe the book was incorrect on their answer on this one. Because the book, even their work, shows the mass going up when you multiply it by 0.8.
We beat the book.
We beat the book.
Can we do 107?
Can we do 78, please?
Sure, 78.
78.
Oh, 78 is super easy. All right, on 78, I have 3 different pressures, right? Yes?
I just long.
It's literally just convert it to ATN, do Pivnert 3 times, then run limiting reactor to.
You did Pivnert 3 times?
12th graders.
You did Pivnert 3 times?
Make your way to the pack lobby.
You go, it's so easy.
Anyone
You're
that
wrong.
missed
All right,
I got the right answer.
pressure,
your way down.
you could get it like that. Or you could do this. Pressure of C3H8 is 0.500 megapascals. Agreed?
Yep.
Yes?
Yeah.
They give me a balanced equation, yes?
Yep.
I know that for every 2 megapascals of C3H,
No shot.
C3H6, H6, I have 2 megapascals of, choose any one of your products,
What the heck?
of C3H3N. Would you agree
No!
that listen, Avogadro's law, pressure and number of particles is essentially the same thing, which means pressure and mass is the same thing. Agreed?
No. No.
So this gives me 2 over 2, 0.500 megapascals of C3H10. You're going to love this. All right, C3H3N. Pressure of N2. Pressure of NH3 was 0.800 megapascals. Agreed? Stoic step. For every 2 megapascals of NH3, I have 2 megapascals of C3H3N. Do you guys see what I'm doing here? What am I doing? So that gives me 0.8 megapascals of C3H3N. Pressure of O2 is equal to 1.500 megapascals. Stay with me.
Wait, what did that say?
1.5 megapascals. Pressure O2, I'm doing the O2 now, times stoic step, I'm just using the coefficients. For every 3 megapascals of O2, I have 2 megapascals of C3H3N. That gave me 1.00 megapascals of C3H3N. Which one's the lowest? Limiting reactant. How many times do I have to do Pivnert now? Only once.
I would rather do Pivnert more than do that.
Right? So I'm going to take this number, which is my limiting reactant. I'm going to convert that to ATM. So my 0.500 megapascals, right, is equal to 0.500 times 10 to the 6 pascals. Agreed? Yes. And we know that there is 1.013 times 10 to the 5th pascals in 1 ATM. So that gave me 4.94 ATM. And now I'm ready to Pivnert. N equals PV over RT. So N equals 4.94 ATM times, what's my volume?
Good question.
150 liters over 0.08206 liters times atmospheres over moles times Kelvin times 298 Kelvin. So that gave me, for a total, 30.3 moles of C3H6. But they didn't ask for moles of C3H6, they asked for what? Grams. So, stoic step, every 1 mole of C3H6 is to 1 mole of C3H3N, and 1 mole of C3H3N is 53.06 grams of C3H whatever,
You leave that up there.
H3N. So I ended up getting 1.61 times 10 to the 3rd grams of C3H3N.
Is that,
Woo!
for the one directly below the pressure of O2, that's megapascals, and then is that pascals to atmospheres?
Where?
Yes, is that pascals?
So I said that 0.500 megapascals is equal to 0.50 times 10 to the 6 pascals.
Yeah.
And then I said that there's 1.013 times 10 to the 5th pascals in 1 ATM. Then I Pivnerted it.
Can you leave that up there for like a second?
Oh, what is that rule?
Can you go,
Okay.
what was it, a freshman? 8th grader?
Probably.
Can you explain why you can do like the top part, like the,
Because Avogadro's law
yeah,
says that pressure in number of particles is directly related, right?
so you wouldn't even like.
Or pressure in mass. No, don't even convert it. So just do it based off the pressures, right? Stoic step it to a pressure, whichever one gives you the least as your limiting reactant. Or you could Pivnert it 3 times. But I just did it like this.
Can you leave that up for us?
Yes.
That's 4.94 atmosphere, right?
Yeah, 4.94. I'm still thinking about 75. Something does not seem right about that to me.
The
I think they
I think
added
we should
one.
forget 75. 75.
I know, but I hate not, something doesn't seem right about
It's
it.
all in our head.
As long as you don't get that on the test.
107, I think.
No, oh, that,
What number?
107 was like,
107?
Aubrey, isn't that one just?
One second.
Maggie, did you want 107 or 137?
I'm on the last
81's just a balance equation and 50.
I don't want to balance the equation.
Okay,
Actually, I'll do it. Fine.
wait, hold on, Mr. Heller, you don't have to do 100 and 101. How would you do that?
So 100, 101?
Equation would-
Okay. So 100. So on 100, it's just pressure of helium plus pressure of H2O is 1 atm. So this is just using the ideal gas law. So 100, the total pressure equals 1, right? pH plus CHO is also equal to 760 torr. I converted, right? So P helium plus 23.8 torr is this. So then you subtract to figure out your pressure of helium.
Can I take a picture?
Sure. So you're just subtracting your total minus your part to get your part of helium. Then toward ATM Pivnert,
Is that 3.69?
3.69.
Oh, I got 3.68.
Fine.
Are you reading Twilight? I love
So that was 100.
And then 101 is the similar.
101 is the same thing. 101 is the same thing. So you get your pressure of O2. Here's 101. So 101, you get your pressure of O2. Convert it to ATM Pivnert.
Can we do 107?
Sure.
Okay, do you have to do Pivnert 3 times? Or is there another special?
For 107, I don't know. I got to look back at my work. Okay, 107. No, you don't have to do Pivnert 3 times.
But that's not wrong, right?
Maybe just get better.
Guys, I just figured out 75. I've been thinking about this whole time.
We know.
It's Mr.
On 75, here's what we should have done.
Mr. Heller's opinion.
It's 0.80 times the total moles of H2. That would equal the 2.1 times 10 to the 5th. That would equal the 2.1 times 10 to the 5th.
So you had to divide it.
So that would make more sense,
What?
right?
Yeah.
That's how, we shouldn't have multiplied it by 0.80. We were actually dividing it by 0.80, which is why the number would have been bigger.
Oh.
That makes a lot more sense.
I still don't get
Yeah,
it.
because if you're losing gas while you're filling.
If you're losing gas,
You need more
Yeah,
to
because
fill
you
it
need
up.
more gas.
yes.
Because always all-
Because you have to put in more gas because you lost some. So what, does that make sense, Jack?
This
Yeah.
was worded.
Also, I wouldn't worry about this problem. Okay? But that's what it should have, that makes more sense now. That makes more sense. Megan, you good with that?
Yes.
Okay. All right, next one. 107?
Yeah, as long as you did Pivnert 3 times instead of
No. That's just not what I would have done. So on 107, I got rocket fuels, dimethylhydrazine. So I have 150 grams. So I'm going to start out with my 150 grams. On 107, 150 grams of CH3-2N2H2 times, that's 60.10. Is that what you guys had? Grams of CH3-2N2H2 in 1 mole of rocket. Okay? And 1 mole of rocket, I'm tired of writing all that, is to 3 moles of N2. Agreed? So I got 7.5 moles of N2. Okay?
Oh, yeah.
So pressure of N2 is going to equal nRT over V. So that's going to equal 7.5 moles times 0.08206 liters times atmospheres. You guys tired of writing that yet?
Yeah.
Times 400 Kelvin over 250 liters. Any questions about where any of those numbers came from?
That's 3 moles of it too, right? 3 moles of it too, for the first one.
Yes. So this gave me 0.98 atmospheres of N2. Right? but we're not done. Because on 107, it's asking for what's the total pressure in the tank, assuming the reaction has 100% yield. So this is based off of, I got 0.98 ATM. How many moles of nitrogen do I have in my problem? What? Yeah, how many moles of nitrogen gas do I have in the problem? What do I have to multiply that by? Times what? What?
Why are we multiplying it by components?
For 107? The two components react. If 150 grams of that reacts with excess dinitrogen tetroxide, the products are collected. What's the partial pressure of nitrogen gas? And what's the total pressure in the tank? Well, I know that my total pressure is going to be what? The total pressure is going to be 3 moles of N2, right? Plus 4 moles of H2O gas. This is just from the balanced equation. Yes? Plus 2 moles of CO2. So that's a total of how many moles of gas? This is how many total moles? That's 9 total moles of gas. That's 9 total moles of gas. So what do I have to do with my 0.98? What do I need to multiply that by?
By 9.
No. By 3. I have to multiply it by 3. Why?
Because it's just nitrogen.
Because it's just nitrogen, and nitrogen is, I have 3 moles of nitrogen, so I just have to multiply that by 3.
Aren't the other ones also gas?
What?
The water and the CO2, are they not also contributing to?
So, here's the thing. I have 9 total moles of gas. Yes? How many moles of those are nitrogen? 3. So, this is the partial pressure of nitrogen. Agreed?
Yes.
So the total pressure is going to be how many times nitrogen?
3 times nitrogen.
3 times to get the total pressure.
Okay.
Does that make sense?
Sure.
I have 9 total moles of gas. In the balanced equation, there's nitrogen is 1/3 of that. We figured out the partial pressure for nitrogen, right?
Oh!
So this 3, right? This, it's like 3 whatever x, right?
Yeah.
Is 0.98. Nitrogen is 1/3 the total mass.
Yeah.
So I have to multiply this by 3 to get the total pressure. That's it.
Okay.
Does that make sense?
Yeah.
So I got 2.9 ATM. So this was the partial pressure of N2, but N2 is 1/3 of the total pressure.
I see.
So multiply by 3 and that gives you your whole pressure for the container. So you did not have to do Pivnert 12 times on that one.
Can you do 120 or 120?
Sure. Any consensus on which one you guys want? Oh, don't get that in my head. What can I say except you're welcome?
Oh, this is the from the package.
Is this the molar mass one?
Yeah, R1 or R2 square root of.
Oh yeah, it would still be good to do one. So let's do 120.
Like 120 is only like the number you get from it.
Yeah, let's do it. Let's do 120. So 120, the rate of effusion was measured at 224 milliliters a minute. Under the same conditions, the rate is 47.8 millimeters per minute. What's the molar mass of the unknown gas? So on 120, we know that rate 1, right, over rate 2 is equal to the square root, yes,
Yes.
of molar mass 2 over molar mass 1.
Okay,
Do we have
why-
to know that
it's
formula?
so weird, but why is it flipped? Like, that makes no sense to my brain. So why is rate 1? Why is it not molar mass 1 or molar mass? Should I just not ask that question?
I honestly don't know. I would have to look that up why, but that's what it is.
Okay.
I don't want to make something up. All right? I'll give you this equation. You don't have to memorize that.
Hey.
Okay? You don't have to memorize that. So, we have rate 1, which is what?
24.
24, yes? So I know that 24, which is what? I don't even care about the units. Is over what? 47.8 is equal to, on 120, the square root, right, of what? 16.04 over x. Solve for x.
Oh.
Square both sides.
So you got to divide this, you got to square it, you're going to square that, and then you should end up getting, for this one, 63.7? Yes? That's fine. So then you're just algebraing it out from there. I have a tummy ache.
Oh.
No.
Did you say L?
Can
Oh my
we do the last one or do not?
What's the last one on the review?
Oh, it's the Johnny.
The Chani boy?
Johnny boy. What is a Johnny boy?
I feel like we can get it done.
If we like ran through it. I have it.
No, I mean, I see the work, I'm not following.
Like it's the molecular.
That one's tough too.
Let's do 145.
This is good.
Let's do 145. The Chani boy is the exact same thing as the old Chani boys, but you have to get one of them with Pivner. That's it. So the Chani boy is the same as the old Chani boys that we were doing, but you have to get one of them with Pivner.
Okay.
145. Oh, this is kind of like that. It's kind of like that. So on 140, it's similar, at least. So on 145, I have CH and N. There's no Pivnerd in this one, but that's still good. I have 3%, right? Well, I have 2%, right? So I can figure out what the third one is, yes? So I have 58, am I on the screen? Yes, I have 58.51 grams of carbon times 12.011 grams of carbon and 1 mole of carbon. I have 7.37 grams of hydrogen times 1.008 grams of hydrogen and 1 mole of hydrogen. And I have 34 from subtraction, right? 34.12 grams of N times 14.007 grams of N and 1 mole of N. So I got 4.872 moles of carbon. I got 7.31 moles of H, and I got 2.435 moles of N. Divide by the smallest. Divide by 2.4, divide by 2.4, divide by 2.4 equals 2 equals 3 equals 1. Therefore, my empirical formula is C2H3N. We good so far?
So it's just like the ones we did in the other chapters?
Right, but we're not done yet.
Remind me of the one.
So this is equal to approximately 2 times 12 is 24. 24 plus 3 is 27. 27 plus 14 is 41. Therefore, my molecular formula, right, on 145, did they give it? They had to give me something, right? Oh, they gave me a molar mass.
Oh, yeah. No. 145, they gave you the rate that helium diffuses.
Right. So we're going to come back to this in a second. They told me that helium, right, is equal to the square root of molar mass 2 over the square root of molar mass 1. Yes?
Yeah.
Which is helium. Yes?
Yeah.
And they just gave me the rate on the left side, which is what? 3.2. So 3.20 is equal to the square root of molar mass 2 over 4.003 grams of He. Now I can figure out my molar mass 2. So once I solve for molar mass 2, it's equal to 41 grams. 41 grams is equal to what? 41 grams. So do I need to multiply any of these?
No.
No. So the molecular formula is also C2H3.
So hypothetically, if your molar mass is like 82, then
It would have multiplied by 2.
Okay.
Yep. Multiplied by 2.
Yeah.
Did you guys hear about fifth period yesterday?
Uh,